Hello and welcome to Rudy's Retro Intel. On today's show I'll be showing off a new board that I've created for the NABU. I call it the NABU PC SMB Z80. It's the signal monitoring board. It's a board that we can plug into the NABU to get some information regarding the power supply, the clock, and what's going on the system control signals for the CPU, the address bus, and the data bus. So let's take a quick or closer look on the card here. So here's the board I created. This has connections on both sides, so you can plug it into your NABU if you want to plug it on this side or this side. There's labels for each of the outputs. So on this side here we have the system and CPU controls. We have the address bus here and the data bus here. Also, we have a spot here for testing the clock signal, and here we have a spot for testing voltages, so the -12, the +12, and +5. In addition, here's a legend of what each signal is, and I've also put a recommended color coding for the LEDs as to what colors should be for what. You can use any colors you like, but these are the colors I thought was best that worked for me. So let's peek inside the NABU and we'll do some diagnostics and show how this works. So here's the NABU board populated. I have resistors here and the related LEDs. I use red for the system controls, green for the CPU control, blue for the address bus, and yellow for the data bus. And on this unit I have here, this is my hardware machine, or for doing my hardware development. I have a floppy drive controller here, and I also have you can see that there's a board inside that is required, an adapter board that is required to make the floppy drive work. Now, generally you're supposed to plug the floppy board onto the first slot. I've moved it over one so that we can actually plug in the diagnostics board. So let's power this up and take some measurements. Now with the board plugged in, I want to point out one thing first. Before we start, I put some rubber feet on there, or plastic feet on the back, so that I can place it on top of the power supply. I've also, I'm not sure if it's coming out clear on the video, but I've added some plastic, or actually rubber double-sided tape or single-sided tape on this side here, so that the +5, +12, and -12 don't short out on the case. So you want to put something on top of that, so you're ensuring that you're not going to fry something. So the nice thing is it sits there. Now let's power it on and take some measurements. We're going to monitor. We're going to check the voltages first. So with that turned on, we can see already lights are already coming on. The fans kicking in. Let's take some measurements. So let's read the +5 volts, and we're getting 4.8. That's good. And the +12. We're getting 12.02, and the -12 we are getting -11.99. So they're all in spec. That's great. So we know the voltage is good. Next, let's hook up the scope and check out the clock. Okay, now we're ready to hook up the scope probe. I have the camera set up so you can see what's going on from above. You can see the board, and we have the I guess it'll be on this side. On that side you're going to see the scope. So let's plug in the scope and check the clock. So on the board there is a ground here, so we can hook up the ground lead to there, and we connect the probe to the pin there, and we can see a signal on the scope, and we can see it is running at 3.5756 megahertz. So we're getting a signal. It's a little it's not perfect square, but that's fine. This is good signal. We're good to go. So I think the next step would be to boot up the floppy drive, and we can take a closer look at the data lights. Okay, let's fire up the NABU. And we're greeted with a message here to insert a floppy disk. The reason why this screen looks a little different than a standard NABU would be the fact that I've updated the ROM. There's a ROM version 14 patched, which is in the board, which allows me then to use the floppy controller, whereas the stock ROM will not. It'll just boot up off the adapter. So as we can see, we have the lights on here. They are the machine cycle, the input-output request, and read and write, which are in red. Also the address encoder. The wait and the reset is green. Now we want to check if the reset's working. We can just press the reset button and you'll see the green light go off. It's off and on. That means that the reset worked. These are active low, meaning that the light is on when it's not active. When the signal is active, the light goes off or starts to flash. So let's get into the floppy drive and see if we can get the information off the data lines, because right now the NABU is not doing anything on the data lines. It's just sitting waiting. The board can be plugged into the stock NABU. You will not see any data lights come up because it's monitoring through the slot on the NABU. So I haven't really played a lot with the stock machine, but with the enhanced machine you're going to see some lights pop up on there. So as you can see, there we go. The lights are flashing. It's not as bright because I think I should change the resistors. These are all set to 330. I think I'm going to make this a slightly lower value and these slightly a higher value to reduce the brightness of the LEDs. As you can see, the blue is pretty bright and the red and the green is coming out really bright too. So here we are in CPM. Let's do a directory and let's change to the boot floppy. I'm using a GoTech, and the GoTech has a little knob on it you can change for different images. So I've picked the main boot one here, and I'm going to run check. We are going to check the disk on the blank image that I have, or it's an empty image. So I'm going to put it's drive A, hit enter or go, and we're going to, yes, we're ready to go. So let's press go, and you can see it's verifying the tracks. But the reason I wanted to show this is that you can see that the data lights are working here. They're flashing. They're doing its thing. So you can use this for your diagnostics or to monitor. You can also plug in your probe on the edge of the resistors on this side to monitor the signals. So you can do that for anything you want on the board. The resistors are usually set flat. In this case, they're set facing up with one of the leg coming out and down. So it's exposing the leg. You can just clip on that. And as you can see, we are going ahead with our verification, and we are getting all the activity. Now the address bus is also flashing, although in the video you're probably not going to see it too well because it's very bright, but here looking at it, you can see it flashing. So again, I'll have to probably play around with the resistors just to reduce the brightness on those and maybe increase the brightness on this ones here. Well, that's it for the video for today. Hope you enjoyed watching this particular video. The board will be available soon on the nabunetwork.com site and my GitHub. You'll be able to download the Gerber files, have the boards sent off, made with your favorite PCB manufacturer, and then it's just a matter of soldering in the LEDs, resistors, and the ribbon cable. Hope you find the video interesting. Leave a like, subscribe, and comment, and we'll talk to you soon. NABU forever.